Hello everyone. Let me share my screen. Hope that everything works as expected. Okay, hopefully you can see my screen. Cool. So, I'm Naim. I'm from GWI, and today I'm going to talk to you about our journey with micro-frontends for the past 3 years. My full name is Naim Gkamperlo, and I am an Associate Director of Engineering at GWI. Now, what do we do in GWI? Long story short, what we do in GWI is we gather data from online users through our questionnaires in around 50 countries as of this Wednesday. We normalize those data, and after crunching them and making various processes on them, what we do is that we offer those data as a service through our platform. Essentially, our platform, so those two images that you can see right here, right now, are from our platform. And essentially, our platform offers 6 ways of visualizing data. Each and every one of those tailored for specific market researchers and regarding their own specific ways of working. What we are going to talk about today is our journey in using micro-frontends for the past 3 years that I have been member of GWI. So every time that you are going to listen to some words from my presentation today, you have to we have to make a small terminology so that we are aware of what we are talking about. So every time that you listen the word MFE, I'm going to refer to micro-frontend. Essentially, micro-frontend can be thought as a specific part of a website written in any language and being part of the greater website, greater application through micro-frontend architecture. If you are familiar with microservices, micro-frontends could be considered something like that for the front-end part. Another thing that you are going to listen to me today storming you with this word is the word kernel. And with this, I mean you are also going to listen this word as shell or platform. This essentially is a system that glues all the micro-frontends. And apart from that, for our context, for the GWI context, it also holds the menu. It holds the homepage, which is debatable. Someone could arguably say that the homepage itself could be a micro-frontend. And last but not least, it loads every micro-frontend upon request, which means that the micro-frontends, along with the kernel, result in a full-blown website, in a full-blown application. On top of those words, it's pretty possible to listen to the acronym CI/CD. With this, we refer to continuous integration and continuous deployment, which essentially is an automated way to build, test, and upload your build code to a predetermined environment. You are going to listen to the keyword front-end configuration, which is a service that provides the kernel with the latest version of all the micro-frontends. And if you speak Greek, I urge you to have a look on last Wednesday's React to React meetup, where we had a full-blown presentation on the approach we have regarding the micro-frontend versioning, although I'm going to say a few words on today's presentation. On top of those, you are going to listen to the acronym CRA or CRA. This refers to the Create React app framework. And last but not least, you are going to listen to the keyword RTL, which refers to React Testing Library. The agenda today, all the next slides that you are going to see are going to have a problem solution format. Mainly, this is my thing, because every time that I attend to a presentation, I would like to be aware of the problem along with the solution that the presenter offers to shed some light on. because I usually forget what we are talking about every now and then. So it's just my thing. In detail now, we are going to shed some light on why we use micro-frontends in GWI. We are going to explore how we develop locally and run globally. We are going to see how we scaled our teams and our coding repositories. Another thing that we will see is micro-frontend versioning that I just said earlier. We are going to have a look on the design system, common components with logic, how we make our micro-frontends communicate with each other. We are going to look at CRA and what we did when it didn't offer Webpack 5 support a year before. We are going to see how we solve the bugs, issues that came up every now and then, how we handle the large bundles, because micro-frontends also could lead to pretty large bundles. Another thing is that we would shed some light on what has worked so far, what hasn't worked at all, but in our context, and also see what's next, at least for our front-end engineers in GWI. So why micro-frontend? Right from the start, we had a very big issue to solve, let's say. We had not one, but two main front-end frameworks, and those were, the first one was L, which also was the legacy code that we had from the previous platform. And what we wanted to introduce was the React framework for our front-end development, which means that somehow those two languages should work together. In addition, we wanted to have single micro-frontend per squad. We wanted to be able to somehow contain the risk of using a new new front-end technology on a micro-frontend level, and not, let's say, start bubbling up and crash our whole front-end website, our whole front-end application. And last but not least, we wanted to separate the deployments of each team. The solution to that, as you have already guessed, are the micro-frontends, which means that we could create micro-frontends either on React or in Elm. And those two worlds were working pretty well with each other. In addition, because we also needed someone to host all those apps, we introduced the kernel. And back then, let's say the main framework that made sense was single SPA, which we also have until now. In addition, part of kernel, again, in our context, are the top menu along with the homepage. And those two are in the kernel repository, written in React and TypeScript. Another thing that we had was that, okay, we have our micro frontend, but we would like to develop it locally and test out only the single parts that this micro frontend actually cares for. However, these micro frontends should also work as part of a larger application, and we should make a way. To make an easy way for developers to make this happen. How we solved that issue was that right from the start, we injected our CRA application, our CRA application. We got our Webpack files and all those stuff. And instead of a single, let's say, entry point for the React application, we had two application endpoints. The first one was referring to the development environment where the micro frontend should work on itself. And the second entry point was that once this micro frontend was part of the greater application, which was part of kernel, essentially. In order to have the second entry point implemented, all we had to do is use the single SPA library and override some of the methods that it offers as part of its API, which you can see at the image on the bottom right. Another thing that we also had to face right from the start was how we would scale our JavaScript team, because as you are all aware, JavaScript is quite not a notorious, let's say, programming language, which doesn't offer some trick, let's say, for developers to be able to scale a team easily. Right from the start, for this reason, we created a single GitHub repo per micro-frontend. Right from the start, we used TypeScript so that we can communicate types instead of just props without knowing their actual types. And we, on top of that, created our custom ESLint. In addition, we didn't use Redux, we used Context API instead to reduce our bundle sizes. We added React Query. There was also a great assistance, let's say, to us, the usage of Axios library for making our HTTP requests, adding it their sectors and handling it on a way that makes sense for us. We also used Material UI, which a year before was rather a pain for us because we had to migrate quite a few stuff. I'll talk about that too later on. And last but not least, the fact that we did have dual entry points was great because it was really easy to develop something locally and make it part of the global application. How we approached micro-frontend versioning. Long story short, when you have a kernel and it has various micro-frontends, a problem that is created from the start is that all those micro-frontends should be supported and have a version for them for all the applications that the company has on all the environments that it supports. What do I mean with environments? We did have, and we do have, a testing environment, staging environment, and a production environment. So we had to somehow keep track of all the latest micro-frontend versions for all of those environments. In addition, we have to create a tool, essentially, that was easy to use by everyone. And by everyone, I mean all the roles of the product trio, that is software engineers, product designers, and product managers. Another requirement was that every time that we make a change and we update the version of a micro-frontend, we want to uncache this version to all the users immediately. Another thing was that we quickly wanted to see and test out features without polluting applications. And without polluting, I mean, you have, let's say, your application production micro-frontends. And in order to be able to test it, even in production, you don't have to destroy, let's say, your production to test out stuff, but rather you have to make, you have to be able to make a clear and clever way to handle these kind of situations. I'm going to shed some light to that too later on. And last but not least, we needed to have maintenance mode, which means that every micro-frontend was turned on or off for the users to be able to see it or not, regardless if we are talking about micro-frontends themselves or even applications themselves. For this reason, we created an internal tool, which we called it micro-frontend configuration, which holds all the latest micro-frontend versions. And in addition, we created feature branches to test stuff on all environments without polluting those environments, as we just said earlier on. A snip of our tool is something like that, where you can see that, for instance, the application that we are talking about is called Platform 2, and all the micro-frontends that it has is, for instance, account settings. And these account settings can be found in storage / account setting staging / assets, and the version actually of the micro-frontend. We are able to either edit this path or update the version directly. We are able to set it to maintenance mode, or we are able to even delete it. I think that also quickly rose was that we needed a shared design system. And once we developed stuff, we also needed to see what we actually developed. How did we handle that? The first thing that we did was that we created a new repository. And this repository, what it did was it held only the UI components shared within all the React-based micro-frontends. Those components had also the GWI theme. Those components were also unit testable using the React testing library or RTL. And last but not least, we didn't hack Webpack. We used the main Webpack feature that is multiple entries per folder. And what we did is that we exported files per component type to reduce the final bundle size. In addition, what we did was that we introduced Storybook. I guess that most of you are familiar with that. We integrated this Storybook with our Figma designs. And last but not least, sorry, as of, I think, previous week, we added accessibility tests, which are automated tests in Storybook, to be sure that all the components that we do have are actually covering all the accessibility standards that are needed so that your applications are either AA, single A, AA, or AAA according to the accessibility standards. This is our GWI theme Storybook. You can see right here, for instance, that we have various UI elements. Those elements can be changed through count right here, or even items label right here, or you can trigger some actions in the other tab. In addition, there is yet another tab right here, which is the connection with Figma, where you can directly see the Figma design that you are implementing, or even the accessibility tab to be sure that you are covering the accessibility standards. Quickly, after we have started developing multiple micro-frontends, because we started low and had only a simple micro-frontend at the very start, at the very beginning, we understood that we needed to have common components that were used across multiple micro-frontends with logic. A very good example in this scenario would be the modals. So there is a modal that we have in GWI, which is called attribute browser, which is needed from 3 micro-frontends. The problem was that those micro-frontends were not only written in React though, and they were also implemented using Elm. So how would we handle this case where something that is implemented, for instance, either in React or in Elm, could be reused by either React or Elm as is? The solution that we found on that, which hasn't helped us a lot, but it did sure solve the problem back then, and it still does, is that what we did is create our implementations either in React or Elm, and as a next step, we build it down as web components using the HTML element wrappers. How do we communicate with those common components? Is that we can pass some state to them by overriding some of their HTML attributes. And also, we can get, let's say, data back from them using browsers' custom events. In addition, regarding the communication between the micro-frontends, not only common components and micro-frontends, but the micro-frontends themselves, we tried to postpone the communication between micro-frontends because we were pretty sure that this could be a Pandora's box for us and it could create chaos. We managed to do this for 2.5 years, but as of this May, if I'm not mistaken, we introduced also the communication between micro-frontends. And how do we handle this scenario? Let's say, again, let's say we have created the kernel to be, we have made the kernel actually becoming a service bus, something like a service bus, which gets messages and shares them to other micro-frontends every time that a micro-frontend would like to open another with some input data. In addition, every time that a micro-frontend would like, for instance, to make a navigation back to another, we could also utilize browser custom events. But I underline that and I add all the exclamation marks of the world. We try to keep communication between micro-frontends at a bare minimum. Another issue that was really a pain a year before was that the Create React app didn't have Webpack 5 support, and we needed to add Webpack 5 because we also wanted to explore module federation, which I'm going to talk about later on. The issue then was that there was completely miscommunication between the people creating the React app along with the Webpack team. And what we did back then, after many trials of trying to make it work, was that we completely ditched all the Create React app files and auto-generated files and all those stuff that are there for almost no reason for everyone. And we created our custom Webpack pipeline. In addition, we added dynamic imports everywhere, which means that we were able to lazy load stuff way easier than before. And on top of that, we were now able to have externals to share common stuff. What do we mean with that? Every time that the kernel was loaded, it also loaded the React library, React DOM, and Material UI, which means that every time a React-based application was loaded, it didn't have to contain in its bundle all of those unneeded stuff because they were passing through the kernel to the needed micro-frontend. So we also reduced the bundle sizes through this stuff. Another problem was, as Dan Abramos says, stuff can break. And we had quite a few bugs. How we handled those bugs, though? Firstly, we created the Cypress end-to-end suite specifically for the new platform that we were creating. In addition, after we have already started this end-to-end suite, sometime in the middle, we started also having a QA team. And this QA team has started creating their own tests. So we managed to create a whole Cypress end-to-end suite, which worked both for the old platform that we had, along with the new platform that we were creating. Another thing that we have utilized is the React testing library for our components. And last but not least, we also have snapshot testing, mainly for our UI components that I showed you earlier with the storybook. Another thing that we had a real issue with is that we had really large bundles because there are, let's say, every time that we build, let's say, web components, those web components, in order to be working properly both in React and in Elm, had to also carry with them quite a few libraries. How did we solve this issue? We made a lot of iterations on this issue, actually. And the first and best was that we start sharing React and common libraries through the kernel using the single SPA import maps. And in addition, what we also do was that during each micro-frontend build time, we also had modular resolution. Last but not least, we had runtime modular resolution using the single SPA import maps, as I said earlier on. And as a result, we had less code that we see, apps loaded faster, and the end user experience was way better. Here, you can have a look of our bundle analyzer on our UI components. You can see everywhere that there is either an index TSX or an index JS, because we both have our output library and our code in the same repository, let's say. And what we can see from this image is that our select boxes are, for some reason, our heaviest implementations. Not sure about that. And now I would like to summarize on what has worked again, for our context and what hasn't. The first thing that hasn't worked for our context was immutable.js. So right from the start, we have added the immutable.js library because we wanted to have a more functional way of writing React. However, there was a requirement that we had to add quite a few stuff on our local storage. And the way that immutable.js works with serialization and deserialization didn't enable us actually make this happen. For this reason, we ditched immutable.js. But again, it's a great library. And if it supports your case, go for it. Another thing that we faced and we had real issues with is we were able to develop locally and deploy something on kernel, but it was pretty possible that mismatches were created because of this asynchronicity. So issues that were created because micro-frontends have, for instance, different material UI version were part of issues created and spotted on kernel. The bad stuff was that those issues were not easily debuggable. And we had to make quite a few efforts to making this, to solve those issues. Sorry. Last but not least, what hasn't worked yet, and this is the reason that I have highlighted this as with a yellow marker, is that we haven't yet managed to deploy module federation on our micro-frontend approach. Why is this the case? Because currently it needs quite a few effort from our side. And unfortunately, we don't have the time from all of our teams to give this effort to make this happen. But in the near future, and by near, I mean by end of 2023, I hope that we have shed some light on that too. What has worked now for us? TypeScript was a great enabler across everything. We were able to communicate even with the backend people because we were able to debug issues which derive from mismatching of types. Another thing that has worked for us is that we used to have Redux right on the start, Redux with sagas, if you are familiar with the library. We completely ditched both and we switched to Context API instead, along with React Query. And this was a huge enabler because, long story short, we had a few kilobytes reduced from our final bundle sizes. Another thing is that by sharing React-related libraries and material UI through kernel, we had seen great improvement in our application load times. The front-end configuration really assisted us with quite a few things that enable us with. And the fact that we implemented feature branches as of this August really enabled us to test stuff even in production without breaking production, which is a miracle for real. And last but not least, the fact that we were able to develop locally something was a great enabler because every time that we make our implementation and wanted to test something out, we didn't have to load the whole site, the whole website, the whole application, but rather we just had to test this little piece of micro frontend that we were working on. Now, what's next for us and what we are looking for the next few months? We are going to revisit on our micro frontend architecture and cutting-edge options. We are going, as I already said, we are going to have a look on actually implementing module federation, which could mean that we will stop using single spa as a result. Another thing is that we are going to have a deeper Figma and Storybook integration, along with automated tests and various stuff. Sorry. Another thing is that we would like to have better React and Elm interoperability, hopefully completely ditching web components, because as I already said, it's quite a few stuff that are carried over without a real reason. And last but not least, we are going to try to auto-generate all the API contracts in TypeScript as TypeScript interfaces or types by either incorporating GraphQL or having a look on our API contracts and creating an automated way to create those interfaces. I am Naim. We are actively looking for multiple front-end engineers in GWI. You can give a try to our platform on this link right here. And thank you very much for your time. So is there anything that I can answer? Is there any question at this point? Okay, I guess there isn't any question. So thank you very much. I'll be here for the next 5 minutes if anyone changes their mind. Thanks a lot. Have a great day.